So I got pulled into a network intrusion discussion. The issue was, how would you create data, convert packet or trace data to a format that could be used to train a machine learning machine model that could then watch your network traffic and see if you had intrusion, right? And so basically the idea is we need to take information about packets and feed them to the training, and then feed that same type of data to the actual execution of the model. So one of the ways that the packets by themselves, I would argue, a lot of people would argue, are not useful on their own, an individual packet. What is interesting or useful is if you can statistically create numbers, features from a group of packets, either a trend or something else. And so in order to do that, what we need is a group of packets. And so if we were to take a stream of packets, what we're going to do is we're going to do this thing called time windowing. So this one here is actually a packet window, which isn't what we're using. In this case, I have a stream of packets moving by, and on regular intervals, we take all the packets that were in that interval between the previous interval and the next one, and we run math against them basically so that we can create features. And then we use those features to try and train a model, and then we take other packet streams, we run a window against it, and we calculate the same number we used to train with, and same type of numbers, and then we feed it to the model to see if it thinks it's intrusion. So again, what we're trying to do is we're trying to increase the scope of the data that we're going to feed to the model. A single packet is not very useful. So the way this will work, a bigger version of this, is if we were to say that the packets started at the bottom and we're basically dropping packets into this stack. What you'll notice here is I have 6 different windows, and the size of the windows in time is the same. What is not the same is the number of messages in each one. So we're going to sliding time window here. What we do is we look at all the packets that were in a window and we combine them in some fashion. And here what we did was we took all those packets, we figured out how many bytes were transferred in that time window, how many TCP messages, how long they were, how many UDP, how long they were, how many ARP, how long they were. Oh, I don't know if that part. TLS, how many of these were TLS, how many were HTTP, and we go down a list of protocols. Because some attacks happen on like SMB, or they happen on SSDP, or they happen on web service discovery. So what we're going to do is we're going to take, the goal of this is to take the incoming packet stream, time slice it, combine the data, and generate numbers that can be used by a model. And if we can do this right, then we could make the model fast enough to semi-pick this up in real time. We'd have to do that kind of conversion and then testing. So this is just a different view of the same thing. What we end up with, right, we took all the packets and then we time windowed and we calculated. We'll end up with just a bunch of records like this, each of which represents a single window. Those numerical values that we use in there, that's what we'll use to try and predict. So the code for this is actually in a repo, and I'm going to talk about this more. But you can see here, this was actually forked off of somebody else's repo and their research project, and I have links in the README to the research project. And then, if you I'll do this in a different talk, but here you can see this is actually a spreadsheet that came out of this, out of one run, training run that we're going to use. So you can see here that we. Like here, we have it turns out there's some HTTP traffic that was windowed in. This is the number of HTTP messages, the number of DHCP, interesting, we have a couple of devices joining, number of DNS calls, the number of NBNS and SMB, and then it turns out we have some web service discovery going on here that was in that time window, the number of UDP and the number of TCP. What was interesting is in this first set of packets, there is no TCP traffic, but there is UDP. So people are at some machines out doing a bunch of broadcasts to go find something. And then this is the number of machine pairs, IP address pairs that showed up in that time window and how many ports were in use. I don't think I have it in here, but one of these you start to see a large growth in the number of ports. And this is how many packets were in the window. And you can see here, as this attack went on, the number of packets went up. You see it drop again here, and you'll see it go up again later if you use this test. So that's it. I just wanted to talk really about time windowing, sliding time windows, and how you would use them to generate features and data that could be used in pattern recognition, statistical analysis, or machine learning training. Have a great day.